Hey, I need you guys all to focus on something real quick. I was not going to get up in your business, but this question was brought to my attention, so you all should focus on this one. It was on the first practice quiz, so a long time ago, a question 11. And I don't think that this is a situation that we've encountered yet, so I wanted to show you. The work, so I hope you're looking at it because this could happen on the quiz. I don't actually know if it will, but this could happen. Um, so again, this is number 11 on the first practice quiz, and it started out as a this or this splitter situation. And when you solve them, you get these. And I wanted to show you what this looks like. So we start, as always, with a number line. And remember that the number line that we draw at this juncture is not an answer, but rather just try to make sense of the situation number line. So if I put these numbers where they properly belong, if I put -1/2 over here, and I put +11/4 over here, what happens is if this were an and situation, so first let's start with the red one. If I have a greater than, then it's going to go this way. And on the purple one, if I have a less than, it's going to go this way. If this were an and situation, then the solutions would be in here. Just FYI, this would be business as usual, but it's not an and situation, it's an or situation. So and means you have to make them both happy, which is why only the yellow shading would work. But an or situation, you have to think about this. If I made a mark right here, that green mark, does that solve this problem? Yes, it does. Because is it making the purple one happy? Yes, it is. If I make a mark over here, a yellow one, does it solve the problem? Yes, it does, because the or means that I don't have to make you both happy, red and purple. I just have to make one of you happy. And so the yellow mark is also a solution. And finally, if I make a white mark right here, does that solve this problem? Yes, it does, because it happens to make them both happy. And an or means you can make one of them work or both of them work. It's a free for all. So we haven't seen a situation like this before. But if you get an or that feels like it winds up looking like a squisher, which this one does, it feels like it should be a squisher, but it's not. And the key is who will identify the word or and its critical nature. An or means you can be anywhere that makes either or both of them happy. Therefore, that's why number 11, the answer is all real numbers, because I can be anywhere on the number line and I will be making at least one of the two constraints happy. So the graph for number 11 winds up just being a fully colored in number line left to right. And the solution is that's why it's all real numbers. So first off, Irene, since you asked, does that make sense? Why that is what it is? We've never seen that before, where one from the right flushes over one from the left. We've seen it go that way with squishers, but never with this. So that's why it's all reals. Make sense? Okay. Anyone else have any questions about that? Okay.
All right. So maybe you should let her. Okay.
What you just need?
No.
So I assume you've set it up. So you should have 1/5 of x plus 4. And do you do your greater than first? Okay. So you'd have is greater than or equal to the normal x plus 1. And then your other one would still be 1/5 of x plus 4, but this one's going to be less than or equal to the double change on the right side, so -x minus 1. Okay, good. And make sure you have the word or. It's that kind of allows us, that's what allows us to make sense of things at the end. So I would multiply everything in both equations by 5. I'm going to assume you did that as well. Did you not do that? Yeah, that's really what you should be doing. So you're going to wind up with 1x plus 20 is greater than or equal to 5x plus 5. And then on the purple one, you're going to have just 1x plus 20 is less than or equal to negative 5x minus 5. So I'm going to assume, based on your physical reaction, that that is not what happened. So listen, that's just working with fractions is not something that we're forced to do. You know, if someone gives you, like on practice quiz 3, there's going to be one problem where I think you have to kill 2 different fractions. So getting rid of them all is a great idea. Do you want me to continue with you? Okay, so on the red one, I'm going to move all my x's to the left. Shh, can you guys please? I'm trying, but geez, Louise. So if we subtract 5x, we're going to get negative 4. And then on the right side, if we subtract the 20 across, we get negative 15. There we go. This is better. And when we divide both sides by negative 4, we're going to get a sign change, right? So we're going to wind up with x is less than or equal to 15 over 4. And then the purple one, we're going to wind up with 6x and negative 25. And we don't have to sign change this one because we're dividing by positive 6. So we wind up with x is less than or equal to just negative 25 over 6. So this is one of these that we're more kind of used to seeing with the ors, where they kind of wash over each other. They don't wash against each other like we saw a few minutes ago on that one that Irene asked about. So this one, they both go to the left. So again, we would draw a number line, and remembering again that this is not a finished product number line, but rather just a showing my work number line. So if I start with 15/4 over here, and then negative 25/6 over here, what happens is they both wind up the key to this is it an and or is it an or? So if it was and, then we'd have to start our solution at the purple, because and means they both have to be true, but or means that you can make either one of them true, which means that the numbers where that red or that yellow X is, those also work. Or means you only have to make one of them happy, remember? So what we see with this is, because of the word or, is that the answer actually starts at 15/4 and works its way to the left. So overall, our solution would be x is less than or equal to 15/4. And then when you graph it, you're just going to have just one constraint, 15/4. Because you see how the 15/4 kind of washes over, like it, I don't know how to say that correctly, but because you only have to make one of them happy, you can be in that center zone. Okay, makes sense? All right, cool.